Fill factor. Fill factor is actually a figure of merit for the PV cell. It tells how good or how bad a PV cell is. It is actually a ratio. Now, before I tell what that ratio is, let us get to it in a much more intuitive manner. Now you see, this is the IV characteristic of a PV cell. Now let me have a projection of along the perpendicular to the voltage axis and a projection of ISC perpendicular to the I axis. And this point is VOC comma ISC point as shown here. Now this VOC ISC, this rectangle here, now let me fill up this area, represents, this point here represents the maximum possible voltage and the maximum possible current that is theoretically possible from the PV cell, but this point will never be reached. Now for a practical characteristic curve like this, the maximum power point is given like this, is VMP and IMP, and it has projections which cover a rectangular area like this. Now observe that when the R series non-ideality is removed, it would gradually become vertical, and R shunt non-ideality is removed, then that would become properly horizontal, and this would be a very ideal cell character. So this point VOC into ISC would be the peak power of such an ideal cell, but this will never happen. This is a more practical cell. Now we need to see how close this area matches with the gray shaded area of a very ideal cell. Now that is how the definition of the fill factor comes. Now consider a PV cell IV characteristic like this, a straight line. This is actually a very bad PV cell characteristic, wherein the series component RS is very large and the shunt component R shunt is very low. Now even if we take such a bad PV cell, we would be getting some power out of it, and let us say we have a VMP IMP point like this, and its projections result in a rectangular area like this. Now you see that this rectangular area is much smaller with respect to the ideal rectangular area as demarcated by VOC ISC. Any normal PV characteristic would have a much higher peak power point and a much larger area with respect to the ideal area. So the area as encompassed by the maximum power point with respect to the idealized maximum power area is defined as the fill factor. So the fill factor is given by VMP IMP divided by VOC ISC. VOC ISC is the rectangular area, the limiting rectangular area, which would be the max possible. VMP IMP is the rectangular area as encompassed with respect to the operating peak power point. The fill factor is the ratio of this area with respect to this area. This tells us or gives us an idea of the goodness of the cell. The more closer this area is to the VOC ISC rectangle, the better the cell. So if you take our typical PV cell, it will be much better than this straight line. It will have a curved line like this. So this practical PV cell characteristic would have a peak power area as shown in blue here, much larger than this green area as shown here, as encompassed by the peak power point of the bad cell. So apparently, just looking at this, you see that this curve, a PV cell having this curve, is much better than this because this area is greater than this. So this ratio, which gives a measure of the goodness of the PV cell, can be computed from the datasheet values. Now if you go back to the datasheet values, you will be able to compute the fill factor for the typical cell of that particular
Look at the datasheet
company
as shown here and bring your focus to these parameters.
So you see here, this is the VMP voltage value and the IMP voltage value. So this would give you VMP IMP. This is the VOC voltage value and the ISC current value, and this would be this one. So plugging in these values into our equation for the fill factor, we get the fill factor value can be computed from the datasheet values: 30.18 VMP into 7.96 IMP divided by 36.72 VOC, 8.99 ISC. Now this will give you a value of 0.72. So this is a ratio. Now 0.72 is a reasonable panel available in the market. If you say fill factor is 0.5, it is very bad cell. If the fill factor is 0.8 or 0.85, it is a very good cell. So that is why FF, or the fill factor, is generally calculated to measure the quality or the goodness of the PV cell.